もじゃん Sorry about that. It's just that I forgot when I joined the Zoom meeting with my 2 accounts, it echoes. I think we're good now, though. No, it's better now. It's better now. Way better. Okay, so now that's there. Okay. Here it is. That's how you guys see it all the way in the back. Different rooms, same. Oh, I didn't need that. I forgot. Just testing. Those that are in the Zoom meeting, can you guys hear me? Okay, cool. Figure it out. All right, so I'll move this out of the way. All right, so good evening, everyone. Welcome to the Math 171, 172 review session. This is our second review session of the semester. So as you know, this review is being presented by Raphael and I, right? We basically run the mathematics and statistics student center, okay? So here are my directions. I gotta fix something here. I wanna move this out of the way just a bit. My bad. I'll put this in the corner. Okay, so let me hit the light rather. I think both of them off is good. Okay. Both okay? Looks good? All right. It's like a movie. Yeah. AMC theaters here. Yeah, that's right. Huh? Say it again? No. Oh, yeah. I'll leave the back one. Sure. There you go. All right. So here are the directions. I know I kind of wrote this a little bit smaller on my end, but I'll just zoom in. So the purpose of review session 2 is to prepare students for their upcoming examination, namely exam number 2, or even their final exam, okay? Many of the questions that I'm gonna do tonight, some of them will be on your second exam, whereas some of the other ones might be on your final, okay? Similar type of problems. During review session number 2, there's a lot that I wanna cover. I wanna do lines, which are, some of its key features like slope, equations, and graphs. Good evening. We're going to talk about functions, such as their limited domains and the difference quotient. We're going to look at graphing transformations and piecewise functions. Quadratic functions, which are, we're going to cover the vertex, max and min, graphs and applications. Polynomial functions, such as using the leading coefficient test, finding zeros, and long division. And lastly, we're going to do rational functions, simplifying, finding their asymptotes, and graphing them, right? So a lot of the problems here you're going to see are definitely graphing, and you're going to see a lot of computations, okay? Step-by-step computations. Please note again that the problems, I did this last time, the problems highlighted in yellow, it's almost all of them, are examples of similar problems that you'll see again on the final exam, okay? So if you don't see a problem on your second exam, better bet that the ones highlighted, you'll see it again for that final. Similar versions. All right, so let's get started. So I'm going to zoom back out. Are you guys able to read what I have so far on the board, such as reading the problems? Okay, so problem number 1 states, use the given conditions to write an equation of the line, of the line in point slope form and slope intercept form, okay? So the line is passing through an ordered pair, 1, -8, and is perpendicular to the line 3x minus 4y equals to 8. All right, so a couple of things here. Number 1, we should know both the point slope and the slope intercept form. We should know what those equations are. Another thing that you should know is, what does it mean when two lines are perpendicular, right? What does it mean about their slope? So let's start with that. With the point slope form, what's that? Clicker? Oh, cool. I can use that. Oh, yeah, just press this button. Oh, there we go. Cool. I never use it. You use this in class? Oh, I never use it. I usually zoom in or highlight if I need to. Okay. So your point slope form. Can somebody tell me what that equation is going to be? What's our point slope form of a line?
Well, don't embarrass me. Yeah, I know this.
Yeah, don't embarrass this guy. Got a pointer on him.
Start picking again.
That's right.
Chris, go ahead. Give the answer.
Parentheses, x minus 1. Parentheses, y minus 1.
You don't really need the parentheses on the y minus. Well, y minus 1 is not the correct way of saying it. You're on the right track with y minus 1, but it's not necessarily a 1 there, yeah? You had your hand up.
Y minus y1. Oh wait, no. M equals y2 minus y1 over x2 minus x1.
That would have been actually the slope of the line. The slope, as long as you know 2 points, the change in y over change in x. But you were saying it originally. Was
y minus y1.
There you go. Y minus y1 equals m.
X minus x1.
There you go. So the way that the point slope form works is that you need a slope m. I'm trying to use this pointer. There you go. Wait, nope, hit the wrong pointer. There you go. You need a slope and you need a point, right? Okay, so that's your point slope form. What about the slope intercept form? Would you like to give me that one as well? That one we should be a little bit more familiar with. Say it again. Mx plus b. What's equal to mx plus b? Yeah. Well, y. Y is equal to mx plus b. There you go. M is our slope, but this time, what does that b stand for? Yeah, b is the y-intercept. Okay. It's good to know. And we know what the y-intercept, you can always write it as an ordered pair. That's 0, comma b. All right, so you have your point slope form, you have your slope intercept form. Now, what do we know about perpendicular lines? More importantly, what do we know about their slopes? What does that imply? If 2 lines are perpendicular? Not quite. That would have been parallel. So parallel, I'll just write it here. Parallel lines have the same slope. So if you had 2 lines and we call them line 1, line 2, then we just said M1, have the same slope. If you had 2 lines, line 1 and line 2, then you would have said that M1 is equal to M2. But we're not using that here because, again, it says that the 2 lines has to be perpendicular. Anybody else? They what? They what on the graph? They will intersect. They will intersect. That's true. Parallel lines they don't, but perpendicular lines they do. But more importantly, I want to know their key features regarding their slope. Yeah? Negative reciprocal, right? So perpendicular lines, my bad. Are negative reciprocal slopes. Okay, so the formula that we need here is that M1 is equal to negative 1 over M2. Okay, once you know the slope of one line, you can always find the slope of another line. Namely, for perpendicular cases, it's negative reciprocals. Okay, so let's attack this problem now. Let's look at the line that's given to us. The line that was given to us was, well, 3x minus 4y equals to 6. Based on that line, can you identify the slope right away? No. Yeah? What is it? Well, just right off the bat, right? Like you're in the batter's box and you're hitting the first pitch. You're going after the first pitch. Negative 3 over what? No. Like I said, right off the bat, can you tell what the slope is? Yes or no? You see he's shaking his head. Say the answer, yes or no? No, you cannot. You have to manipulate it a little bit algebraically. What you want to do with that equation, I'll show you in a second. But what you're going to have to do is write it in y equals mx plus b form. You write it in y equals mx plus b form, so that way you can find the value of m. Okay, so if we begin with line 1, right, we have line 1 is 3x minus 4y is equal to 6. You write this equation in y equals mx plus b form when you solve for y. So if I solve for y, what do I do first? Say it again. That's right, you move the 3x to the other side. But if you move the 3x to the other side, am I just adding 3x on both sides? You subtract the 3x on both sides. So we subtract 3x on both sides. We're going to get negative 4y is equal to negative 3x plus 6. Okay. Now, how do I get y even further? How can I get y by itself? That's right. You divide every single term by negative 4. So negative 4y over 4, the negative 4s will cancel. That will give us y by itself. That's what we wanted. And it's now going to equal to, well, let's see what happens. What's negative 3x divided by negative 4? What happens to the two negatives? The negatives will cancel. That's right. So you're left with 3 over 4x. And then 6 over negative 4, you could have reduced that if you like. You could have said that's what? Well, 2 goes into both of them. Yeah. Say it again. That's right. 3 over negative 2, or you could just say negative 3/2. Okay. You could just say negative 3/2. All right. So that's your line 1 in y equals mx plus b form. We did all of that, so that way we can establish or identify the value of m1, your slope, right? What is my since I call that line L1, we use m1 for its slope. What is m1 going to be equal to? 3 over 4. So m1 is equal to 3 over 4. All right, if m1 is equal to 3 over 4, then what do I know about m2? It has to be a negative reciprocal. So first of all, m1, is it positive or negative? It's positive. So that would imply that m2 is going to be what type of value, positive or negative? It has to be a negative value. Okay, and now you take its reciprocal. So what's the reciprocal of 3 over 4? 4 over 3. So you got m2 is negative 4 over 3. All right, so we can go ahead now. We have enough information to write the equation now in point slope form. How do I know that? Well, we're writing the point slope form and the slope intercept form for line 2, the line that we actually want to find. So we're going to be using m2 equals negative 4/3 and the given point. So I just got to go back to the problem. What was the given point in this problem? What do we know about the point that this line is passing through? Yeah, Edgar, want to say it? No, Eric or Edgar? I forgot your name. No, want to say it? That's all. 1 comma negative 8. Right, just put a comma between it because you're saying the order pair. So you're using m2 equals negative 4/3 and our point, which is 1 negative 8. Okay, so we can do the point slope form. So I'm just going to slide this back down. So we have y minus y1 equals m2 times x minus x1. All right, so when you plug your values in, you get y minus negative 8 equals negative 4/3 times x minus 1. And those, when you're solving this on MyLab, you have to simplify this just a tad bit, where whenever you see two negatives, you turn it into a positive, okay? So if you look at the left-hand side of the equation, the final answer for point slope form would have now been y plus 8 because there's two negatives there. So you get y plus 8 equals negative 4/3 x minus 1. That's just the point slope form. Any questions so far? All right, now that you got the point slope form, you go ahead and find the equation of the line in slope-intercept form. To get the equation of the line in slope-intercept form, all you got to do is just rewrite this equation where you're isolating y by itself. Okay, it has to mimic y equals mx plus b. Okay, so now in slope-intercept form, we start back where we left off. That was the y plus 8 equals negative 4/3 times x minus 1. What we can do is the following. We can distribute the negative 4/3 inside the parentheses. This will give us y plus 8 equals negative 4/3 x. Negative 4/3 times negative 1 will be what? It has to be a positive number, so we say positive 4/3. Okay. So we did the distributive part. So that takes care of the right-hand side for now. But on this left-hand side, it's y plus 8. So how do I get y by itself? You can't say plus 8. Subtract 8. You subtract 8 on both sides. Okay, so when we subtract 8 on both sides, the 8's on the left will cancel. That will give us y by itself equals negative 4/3 of x. I'm going to zoom in a bit so that way we have more, we can see a little bit more. Negative 4/3 x plus 4/3 minus 8. All right. So now the last thing I have to do here is just take care of the 4/3 minus 8 part. Once I take care of that, I can solve, I can write out the final answer. Give me 1 second. Let me just save some room here. Okay, so this is just going to be a side for us. Let's take care of that. So we have 4/3 minus 8. So can I just subtract 4 from 8 and say it's divided by 3, or do I have to do something else? No, you only apply keep, change, flip if we're hungry. Think about candy chicken fried. No, that would be only if you're dividing by fractions. So here we're only subtracting. You find a common denominator. So you can rewrite 8 as a fraction, 8/1. Okay. And now you find your LCD. So what's your LCD between 3 and 1? Is it 3? So there's nothing to change with 4/3, but we can change the 8/1. Well, 1 times what gives us 3? 3. So I multiply 3 both top and bottom. So I did that on the bottom, now I do it on the top. 8 times what gives us, 8 times 3 gives us what? 24. So we have 4/3 minus 24/3, and that's going to equal to what? Say it again. Negative 20/3. Okay, so that will be your difference. So our final answer here, it's going to zoom back, zoom this on this side here. Let's move this out of the way. So our final answer is going to be y equals negative 4/3 of x minus 20/3. Okay, that is your slope-intercept form, and above it, you have your point slope form. Anybody want to ask me some questions? Or do you want me to zoom this back out? You guys can see what I'm writing on the board, right? You guys don't have any troubles with that. Any questions? I know you guys copy it. When I zoom out, you can still see it? Everybody? Cool? All right. While you're copying the bottom half, just gonna look at, do I have enough room? Okay, I think I have enough room. Let me just close off the thing on the top. Okay, so let's look at problem number 2 as you still copy in the top of this. So problem number 2 states, write the equation of the line in slope-intercept form based on the given graph. So again, what is the slope-intercept form? Say it louder. Y equals mx plus b. Again, m stands for your slope, and the way that we compute it is how you mentioned it earlier, right? Can you just restate it for us? How do you compute the slope? That's right, y2 minus y1 over x2 minus x1. Okay, and we know b stands for the y-intercept, which is the order pair 0, comma b. So the good thing about this graph, this equation of the line, is that there's 2 key points that you should distinguish right away. What's one key point that you see here? Can you give me the order pair for it? 2, 6 is not on this graph, unfortunately. 2, 6 is up here. Oh, my bad. 2, 6 would have been here, so it's not part of the line. But yes, 0, 6 is. And 0, 6 represents what? That's your y-intercept. Okay, so I know that automatically, and that y equals mx plus b, the final answer should end with a plus 6. All I got to figure out is the value of m. If you want to figure out the value of m, all you need is 2 points. So I got 1 point here. I got the y-intercept. What's another point I could use? 2, comma 0. And what do we know about 2, comma 0? That's you can use the x-intercept. Okay. So you find the value of m. You could have labeled your 2 points. You could have said that's your x1, y1, x2, y2. Plug it into your slope formula. Find the value of m, plug in the value of b, and you get your final answer. All right, so m equals the change in y, so it's 0 minus 6 over 2 minus 0. So what's 0 minus 6? Negative 3. 2 minus 0? Oh, sorry. I was thinking about the final answer. Oops. 0 minus 6 is negative 6, and 2 minus 0 is 2. Yep. That's right. So m is equal to negative 6 over 2, and you can reduce this to my spoiler alert, as Raphael mentioned, it's negative 3. So since m is equal to negative 3, and b is equal to 6, our equation of the line is going to be y equals negative 3x plus 6. And done. That's it. That's all it is to that problem. What makes this problem work was that one of the key points was finding the y-intercept, okay? Because I don't have to go ahead and use the point slope form, just find the value of m, I know what b is, put it together. Questions? All right, can we continue? Sounds good. Let's look at problem 3. Problem 3 states, let f of x equals x squared minus 5x minus 6, and g of x equals x squared minus 36. Simplify and state the domain of f over g. F of x divided by g of x. So when I look at this notation, f of x over g of x, what should be like your red flag? What's one thing that we can't do in math? Look at the way this expression is written. It resembles what? Say it again. That's right. Whatever's in your denominator cannot be equal to 0, because in math, we can't divide by 0. So the way that we write this out is saying the following: f of x over g of x. The semicolon just basically means provided that your denominator, g of x, cannot be equal to 0, right? There's some values of x will make the bottom function 0. Whatever values that are, those are, we have to exclude them from our domain. Okay? So here's how this goes. So we begin by saying that f of x over g of x is equal to the following: x squared minus 5x minus 6 over x squared minus 36. So when I'm dealing with rational expressions, I have like how do I put it? It's like one of my habits. It's like anytime I'm dealing with these type of expressions, I always like to write it in factor form, if I can. Right? If you could write it in factor form, go ahead. So for example, look at the numerator: x squared minus 5x minus 6. Can you write that numerator in factor form? And yeah, there's two numbers that when you multiply them, that gives you -6. That adds up to -5. What are they? 1 and -6. Yes. So we say x minus 6 times x plus 1 over x squared minus 36. So x squared minus 36. How can I factor that? What does that resemble?
X plus 6, x minus 6.
Mm-hmm. What type of factoring technique did you use? What's the name of that? Yeah, it's gonna be, if you know, yeah. Gotta build on that a little bit. It's not just a binomial. Well, why can't we say it's x minus 6 times x plus 6? What is it called? No.
Think about this.
There you go. Who said it? In the back? Yes, it's a difference of two perfect squares. It's x minus 6, x plus 6. It resembles two squares with a subtraction sign between them, right? X squared is x raised to the second power. Well, what number squared gives you 36? 6, right? So it's a difference of two perfect squares. All right, so the problem does say that you want to simplify and state your domain. I gotta give Johnson this back. Give me the pointer. I left his pointer.
No, I can't point one.
That's right. So one thing to note is that it says to simplify and state the domain. The thing about it is students will go right away and cancel out the x minus 6s because that's the common factor. But just note that whatever domain issues you have here, whatever domain issues is going on, it carries over to the simplified version of the function. Okay. So what values of x, if you just look at your denominator in factor form, what values of x makes this denominator 0? 6 and -6. So x cannot be equal to -6. X cannot be equal to +6. Or you could have just said plus or minus 6, right? You see how you do that intuitively? You just look at each of the factors, said x minus 6 is equal to 0, said x plus 6 equal to 0, and you solve for x. You got your -6 and +6. So since those are your problematic inputs, when you simplify this function, this domain issue carries over, okay? So since the x minus 6 can be canceled out of the common factors, you're going to get that f of x over g of x in the simplified form is x plus 1 over x plus 6, provided that x is not equal to plus or minus 6. Okay, so we simplify the function. Now you can give your domain. Here I just talked about on the right-hand side of that simplified function, I only talked about the problematic inputs. If you actually want to write out the domain of your function, you can do it in words, you can do it in a graph or interval notation, right? In words, you usually say that the domain, right? So I'm just going to do all three cases. Your domain is all real numbers except when x is equal to 6 and x equals -6, okay? That's how you write your domain. Domain is all real numbers except when x is equal to those two values. Now, if you think about it from a number line perspective, right? On one end, you will have negative infinity, positive infinity, and then somewhere you'll have your negative 6 and 6. Now, because we're excluding negative 6 and 6, should they be part of my graph? No. So how can I represent that they're not part of my graph? A circle. In particular, is it a shaded circle, a closed circle, or an open circle? This has to be an open circle. So I have an open circle at the negative 6 and the positive 6, but my domain now could be anything else. So I'm basically bypassing the negative 6 and I'm bypassing the positive 6. So if you think about your number line here, right, from this visual representation, that one number line, a whole number line, think of it as this ruler, this number line, it was broken into how many parts because of those two problematic inputs? 3 parts. That would tell me that I need 3 intervals. Okay? So if I read this from left to right, what would be my first interval? Negative infinity to negative 6. So we use parentheses here because we're excluding everything. So it's negative infinity to negative 6, namely with negative infinity, by the way, it's an idea. It's not an actual real number. Okay, now that's the first interval. The second interval would be what? You have to do an not intersection, but a union. Use a union symbol, and then you talk about the second interval. That will be what? Negative 6 to 6, and then the third interval. Careful, we're going left to right. So what's all the way at the right? Positive infinity. That's right. And that's your interval notation. So if you ever have stuck with the interval notation, think about the number line. Okay? Think about your number line. Any questions? Now just be careful with this problem. You got to make sure you read it carefully. Sometimes it will say simplify it, or sometimes it will say state it, the domain, or sometimes it will say both. We did both. Okay? So it's important that you make sure you read this problem carefully. You might have to do one or the other or both. That's all I'm saying. Any questions? We can move on to problem 4. All right, so problem number 4 states, let f of x equals 2x squared minus 3x plus 4. And you got to compute and simplify the difference quotient.
What's that?
Yeah, what's that? What? Difference quotient? Yeah, I don't know. The students tell me. What's the difference quotient? Anybody remember the formula that we use for the difference quotient? Careful, there's an over h part. I'll give you that part. We are dividing by an h. But what goes on the top? There you go. You have f of x plus h minus f of x, and then you divide by h, right? As long as h is not 0, okay? Okay, we can't divide by 0. All right, so the way that I do this is as follows. I compute f of x plus h first, right? Figure out what's that piece. Then I subtract, I take the difference in the numerator. And then lastly, I simplify where I divide by h. So let me show you. So we have to first compute f of x plus h. Well, look at your function f of x. It's 2x squared minus 3x plus 4. How many x's appear in that function? 2, right? One of them went with the x squared, and one is obviously went with the negative 3x. So I have to replace both of those x's with x plus h. This will give us 2 times x plus h squared minus 3 times x plus h plus 4. Now I have to compute this, which means I have to expand it. Okay, I have to expand it. So let's take care of the x plus h squared. Let's take care of that piece, and then I'll be able to expand this whole entire thing. So when you look at this expression, right, I'll just do this on the top. I'll call it a side. if I have x plus h squared, what does that mean? How's another way I can interpret x plus h squared?
You have to distribute on this part of x and h.
Unfortunately, no, because there's a plus sign between them. So unfortunately, no, I just can't take the squared and say that's x squared and that's h squared. No. Anybody else? What does the x plus h squared interpret as? You multiply it by x plus h by itself, right? So it's the same thing as saying x plus h times x plus h. Now, if you do multiply this by itself, right? What type of, what method is that? Say it louder. It's foiling, right? It's foiling. So you're gonna take x times x. So what's x times x? X squared. Then you take x times h, which is xh. Then you take h times x, which is, it's like saying hx, but hx is the same thing as xh. Okay, so it's xh, and then we take the h times h. So what's h times h? A squared. Okay, is there anything I could combine there? xh. How many xh's do we have? 2. Right, so this is actually x squared plus 2xh plus h squared. So I'm going to make that replacement back when we were computing f of x plus h. This is 2 times x squared plus 2xh plus h squared minus 3 times x plus h plus 4. Okay, so if you want to expand this now a little further, what do we do? That's right. You know, you're going to distribute the 2. Is there anything else I could distribute? The -3. So this gives us the following. 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 4. Okay, we got the f of x plus h part. Now we can do the difference in the numerator and then divide by h. Okay, so we just save a little bit of room here. So here's how this goes. So from the formula, what I like to do is keep the f of x plus h terms and f of x terms separated by brackets, right? In between them, I'll have the minus signs. So I'll have 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 4 minus the original function, the 2x squared minus 3x plus 4. And all of this being divided by an h. The good thing by separating the terms with by the brackets there is whatever they have in common, because of the minus sign, things can get canceled out. So what terms can I get rid of?
That's from
2x squared, right? You got to say the whole term completely. The 2x squares are gone. What else can I get rid of?
3x.
Yeah, you could get rid of the -3x and the 4. So notice that the terms of the original function, 2x squared minus 3x plus 4, the original function, those are the terms that are being eliminated. The terms that stay are the ones that involve an h, okay? So you get 4xh plus 2h squared minus 3h, all divided by an h. All right, so because all the terms in the numerator contain an h, what can I do to that h in the numerator? You can take it out, you can factor it out. If I factor out that h from the numerator, then what do I have inside the parentheses? 4x plus 2h minus 3, all divided by h. So if h is not equal to 0, your h's are gone, and what you have inside the parentheses now is your final answer. 4x plus 2h minus 3. Any questions? Yeah, in the back? Why did they cancel out? Oh, because technically speaking, negative 3x minus negative 3x is the same thing as saying negative 3x plus 3x. Okay, and you can read that backwards as 3x minus 3x, which is 0. Right, so this is what I was saying. Negative 3x minus negative 3x is technically the same thing as saying negative 3x plus 3x because there's two negatives together. But you can read this backwards if it helps. You can say that's 3x minus 3x, which is 0. Okay. But what I want you to recognize, right, is that because you have the brackets separating the terms of f of x plus h from the f of x terms, and you have a minus sign between them, then whatever terms you have in common, because of the minus sign, you just get rid of. Okay. You just get rid of it. The only terms that should remain are terms that include a h. Sounds good? Yeah.
Even though it's like 2h squared, you know, take out h, it's still gonna have remaining h at the end.
Yes. The idea to this comes in calculus. Why that one particular h is still there.
Think about it. You could also break up each term and treat them all individually instead of factoring to do that. Instead, you also.
Oh yeah. Another way of looking at it is that h squared, right, is like h times h. So if you divide by h, a pair of the h's are canceled out. One h is remaining on the top. That's another way. But the implication is because of calculus.
They mentioned that in class.
I was there for that.
Oh.
Yeah.
I'll save it for your calculus appetite. I won't do it here.
So I feed the level.
Sounds good. Sounds good. Any questions? Okay. Can I move on to problem 5? All right. So problem number 5 states that we want to discuss the transformations and sketch the graph of y equals the absolute value of x minus 3 plus 5. When you think about the absolute value, what does this graph look like? Its general shape. It's a V. It's a V shape. That's right. It's a V. All right. So I know that this graph automatically resembles this shape. Oh, sorry. It's a V shape. Okay. It resembles a V shape. What we want to do is use transformations to help us sketch our graph. All right. So let's begin with this minus 3. Is the minus 3 inside the absolute value or is it outside of the absolute value bars? Inside. If the minus 3 is inside of the absolute, like for example, how the minus 3 is inside the absolute value bars, it tells us that we're either going to move left or right. But it really comes down to the sign of it. Okay. So the negative 3, what do you think? Are we going to move left or right? Right. So I'm just going to write this in words. The negative 3 tells us that we're going to shift 3 units to the right. Okay. What about that positive 5 now that's on the outside? Say it again. Yep, you shift 5 units up. All right. So we can now use the transformations here to sketch our graph. So technically speaking, if we were to begin with the absolute value of x, right? Just this equation, y equals absolute value of x. Where is its anchor point? Do anybody remember? 0, 0. Is that the origin, right? So y equals the absolute value of x. This is just a little side note. The anchor point, its vertex, is at the origin. Okay, so it's going to be this point. So I'm literally going to take that point, that origin now, and I'm just going to shift it 3 units to the right, then 5 units up to get my new anchor point. Okay. So if I go 3 units to the right, 1, 2, 3, then 5 units up, we get the anchor point for our graph, right? That's going to be the point 3, 5. And now your V shape, is it going to be opening up or down? Careful, it's not down, it's going to be up, right? How do I know it's going to be up? If you look at your equation again, is there a negative sign in front of that absolute value bar? No. The negative would have implied that you would have to reflect in the x-axis. It was in front of the absolute value bar. But since there's none, you just open it up. Okay. So that would have been your graph y equals the absolute value of x minus 3 plus 5. But just to show you, if it was y equals negative absolute value of x minus 3 plus 5, then this would have been opening down. So what I have there in red is, again, y equals negative absolute value x minus 3 plus 5. It reflects in the one in red reflects in the x-axis. Basically tells the v flip upside down. Sounds good? Transformations, I don't think you should get them wrong. Be honest. Transformation is not that bad.
Unless you're in my class and then you get purple.
Oh yeah, he's gonna throw some curveballs.
You're gonna get a big hint. Well, that'll give you next week. So I have a negative sign in front of this if I give you an absolute value.
Yep. So which one will it look like? The one in black or the one in red? The red. I'm gonna show you my curveball. I usually give this as a gimme one. This is like the gimme one. My next problem is the curveball. That's right. If you can't hit the heater, then you got to hit the changeup.
Actually, unless it's Chapman, it's very difficult.
If Chapman's pitching, I'm scared for my life. He doesn't have his control. Exactly.
That's what I guess.
Mm-hmm. We're on to problem 6. Okay, so problem 6 states to discuss the transformation and sketch the graph of y equals now the square root of x minus 6 minus 6. What I'm saying 6 minus 6. Okay, so we have to discuss transformation here, but this problem is much different from oh yeah. So this problem is much different from the previous example. And I'll show you why. Look back to problem 5. In problem 5, look at our x. Was there a negative sign in front of the x there? No, it was actually in front of the function. Because it was in front of the function, that would have told us to do the upside down part. Here, we have a negative now that's inside of the square root function, but in particular, it's associated to the x. Okay, so one thing that you can do with problem 6 is to rewrite the function. One way that you can rewrite this function is by factoring, right? If I want to rewrite this by factoring, I'm doing it in such a way where the x becomes positive. So if I want to make that x become positive, then what should you think I should factor from inside of the square root? Say it again. What am I factoring out? We're factoring out the negative because I want to make it positive. So this will give us y equals the square root of negative, in parentheses, negative 6 plus x. Okay. If I pull the negative out, or just factor a negative out, then the 6 becomes negative, the x becomes positive. that allows me to rewrite the inside of that parentheses, the -6 plus x. I can rewrite it in its reverse. This will give us y equals the square root of negative x, in parentheses, x minus 6. And now I could take care of the transformation to this problem. Let's begin with the -6 part. What does that -6 tells us to do? Shift 6 units to the right. Shift 6 units to the right. Okay, so we take care of the -6. That part is done for us. But now I got to take care of this negative that's still inside of the square root. That's okay. What does that negative, the one that's inside of the square root there, the one I circled, what does that tell us? Say again? It's going to reflect, yes, but it's not reflecting upside down now. It's going the other direction. That other direction, think about your axis. You have an x-axis and you have a y-axis. So if you're reflecting going this way, you're reflecting in the y-axis. Right? So the negative means that you reflect in the y-axis. Okay, so I have enough information now to sketch my graph. What it looks like is the following. Technically speaking, if we begin with y equals the square root of x, where's the anchor point located? 0, 0. So I'm going to do that one in blue. Okay, so it's located here. And what would the graph of the square root function look like? Yeah, it sort of looks like you're going fishing, right? And you're throwing out the rod, and like you got the hook part, but the hook part never touches like the water. It's like, you're throwing out that hook. Yeah, bless you. You're welcome. There you go. So that is y equals the square root of x. Now, if I want to do y equals the square root of negative in parentheses x minus 6, then I go 6 units to the right. 1, 2, 3, 4, 5, 6. Let's say that's that point in red. And now I'm drawing that same curve, but in the opposite direction. Right? It's reflecting in that y-axis. Right, so what I have here in red is y equals the square root of negative x minus 6, or 6 minus x. Any questions? Yeah?
But how would it be if it's like that when the negative's outside the bracket?
If it's outside of the bracket, then okay, let's say it was outside but never inside. Okay, then I change the colors. It would have been this way in purple. Okay, so what I have here in purple is y equals negative square root x minus 6. Now, if you have both of the negatives, you got to put the ideas together. Bless you. You know that if the negative is on the outside, it flips down, right? But if you had a negative inside, then it has to reflect back this way. So if you had 2 negatives, doesn't make a positive here. You'll get, oh, sorry, that's the wrong color. You get something like this. So you start at your anchor point in red. That would have been 6, 0. And it would have went that way. So it's y equals negative square root negative x minus 6, which is crazy. That's right. But there's a reason why I give the 1 in red. There's reasons to my madness. You don't have to do this with shifting either. You can do this with just understanding domains of functions. Okay. Let's look back at y equals the square root of x. If you look at y equals square root of x, can I evaluate x for all real numbers? Can I plug in any real number I want and say that I could get the square root of that value? No, not in the real number system, right? What type of numbers are the problematic inputs here? No, not that they're perfect squares. Yeah.
I'll say like 6.
No, six is no. I could plug six and I get a real number back. It's not perfect as a decimal representation. It's an irrational number. That's fine. It's still a real number, huh? Say again. No, I could plug pi. I could definitely plug pi. Still, I can still plug that in and get something. Say again. That's right. It has to be greater or equal to 0. That's absolutely correct. You see, y equals square root of x is true as long as x is greater or equal to 0. As long as x is 0 or a positive number. Okay. So if I have y equals the square root of x minus 6 minus x, that's true as long as that inside of that radical is either 0 or positive, right? So y equals square root of 6 minus x. This is true as long as this piece is greater or equal to 0. If I were to set this equation now equal to 0, greater or equal to 0, right? Set up the inequality. I get my domain, right? If I take 6 minus x greater or equal to 0, solve for x, you get your domain. How do you solve for this inequality? Subtract 6 on both sides. You're going to get negative x is greater or equal to negative 6. Then to get x by itself, you would divide by negative 1. But if I divide by negative 1 on both sides, right? You get x, negative x over negative 1 is x. Negative 6 over negative 1 is 6. But that greater or equal to then symbol, because you're dividing by a negative number, what happens to that symbol? Not that it becomes positive, it changes. It goes in the opposite direction. You get x is less than or equal to 6. That's your domain. If you look at the graph in red, well, from left to right, that's negative infinity to 6. So it's all the way at the very left, but where does it end at? It ends at 6. If I were to plug in any number now, greater than 6, no good. So if you understand domains, you could have also graphed this equation based off domains. Just saying. Any questions? We did a lot here. Did a lot in this one problem. Let me know. Any questions? Are you guys you're okay to move on? Yeah?
So you wrote a lot here. I always want to know, what is the endpoint here?
What?
Where do we end at? Because
Oh, what's the final answer?
yeah,
What's in red? The solid. So basically the final answer was just that. Okay. Basically,
I was not confused.
yeah, no, it starts basically with a negative 6, then the negative in the quotes. Because of what I did on the right hand side, right? I did some factoring techniques there, where I could show you that you could pull the negative away from that x, and then you're allowed to use transformations as shown. Okay,
Like, what's the best way to like memorize it? Now it's
it's just practice. Do the homeworks. Do the MyLabs. Anybody else? Question? All right, let's move on. Problem 7. So problem 7 states graphing piecewise functions. Have you done this in your class yet? I've graphed them? Okay. So we want to graph f of x equals negative 2x plus 5, provided that x is less than 0. And x squared minus 5, provided that x is greater or equal to 0. So the way that you graph your piecewise function is looking at where your domain changes at. So what value at what value of x is the two equations changing? Look at the function. You have two equations separated by specific domains. So where does the rule or your domain is changing at? What value of x? It's right there. Say it louder. 0. Right? In this problem, your domain changes at x equals 0. Right? Look at the first inequality symbol. The first inequality symbol states less than. X is less than 0. Is 0 included there? No. So the first equation is true for any negative numbers. You could plug in from negative infinity all the way up to any number, but any negative number you want, but we're not including 0 there. Okay, so what you're going to do is figure out where the domain changes. That was done. Now you're going to evaluate both of your equations at 0. The reason why you're doing this is that when you're doing a piecewise function, at where the domain changes, you have an open point versus a closed point. So looking at equation 1, which was y equals negative 2x plus 5, I'm going to plug in 0. If I plug in 0, this will read as negative 2 times 0 plus 5. Well, what's negative 2 times 0 plus 5? 0 plus 5, which is 5. So your first equation has this order pair 0, 5. But again, the first equation is true whenever x is less than 0. So this order pair 0, 5 is going to be an open point or enclosed point. It's going to be an open point, right? So this order pair here that I just drew is an open point. Okay, now we move on to equation 2. Equation 2 is x squared, we could say y equals x squared minus 5. So if I replace the x with 0, we get negative 2 times, we get 0 squared minus 5, which is, you get negative 5. So as an ordered pair, this will be what? 0, negative 5. Now look at your inequality symbol for equation 2. It's x squared minus 5, provided that x is greater or equal to 0. So this is going to be an open or a closed point? You have a closed point, and now you can make your sketch of your graph. So here is your y-axis. Here's your x-axis. So I plot those two things. Let's just say for the purpose of this, my scaling, let's say this is 5, and let's just say this is negative 5. Then at the order pair 0, 5, I have an open point, right? I'll make that bigger. Open point. At negative 5, 0, negative 5, it's a closed point, okay? Now we use the features of these two equations to make our graph. For example, look at equation 1 again. Y equals negative 2x plus 5. What type of graph, what would that graph look like? It's a line. It's a line. And because y equals negative 2x plus 5 is a line, one thing that you should recognize is its slope. What is its slope? Negative 2. And if it's negative, then what does that imply about the line? Is it going to increase or decrease? Decrease, right? So for our equation 1, again, y equals negative 2x plus 5. You should recognize it's a line. In particular, m is equal to negative 2. So that tells us that the line should be decreasing, okay? Which I showed on the bottom there. So from left to right, that line is decreasing. You could have plugged in ordered pairs as well. Like you could have plugged in values of x equals -1, x equals -2 to do that. But because you've already studied lines, and hopefully you studied quadratics, parabolas, then you don't need to do the point plotting. Just use the features of these graphs. Okay, look at x squared minus 5. For that equation, y equals x squared minus 5, that's a, what does this graph look like? A parabola. And what's the shape of a parabola? A U. But be careful here. Am I doing a full-blown U? No. Why is that? What's the vertex of this equation? X squared minus 5. What's the vertex? What is your, yeah. If you think about the parabola being sketched here, what would have been its vertex? You could have did this with a little bit with shifting. Well, yes, -5, but that would have been the y value. What's the x value? 0. You have 0, -5. Right? If this was I just wanted to graph the general x squared minus 5, it'll look something like this. Okay, but that's not the case here in this problem. Why is it not the case? Look at the values of x that we're plugging in. The values of x that we're plugging in starts at 0 and it goes all the way to infinity. So technically saying that instead of saying that we have a full-blown parabola, we're going to have what of a parabola? Half of it. That's right. You get half of a parabola. Okay, and that's it. The first equation is shown using a line. That was y equals -2x plus 5, provided that x was less than 0. Here, the parabola, half of it is x squared minus 5, provided that x was greater or equal to 0. Okay. Any questions?
You have to label it.
I labeled it. I just labeled it. I think your professor would recognize. If you're doing this by hand, your professor should recognize what you did. All right, can we continue? Okay, let's look at problem 8. So problem 8, now we're going to get into the quadratic stuff. Problem 8 states, suppose f of x is equal to -x squared plus 8x minus 18. Find the axis of symmetry, find the vertex, and determine whether there's a maximum or minimum value, and then graph the function. So, anybody know how to find the axis of symmetry? I know that thing gets overlooked sometime, but anybody know the equation that we use to find axis of symmetry? No? Okay. To find the axis of symmetry is basically the first step into finding the vertex. So how do you find the vertex? How do you find the x coordinate of the vertex? No, you don't set it to 0. That's right. To find to find your vertex, right? You would first set the get the x coordinate. You say x is equal to -b over 2a. That's the same thing as for finding the axis of symmetry, right? Because if you think about a parabola when it's being drawn, right? Here's the vertex. Okay. Your vertex and this axis of symmetry, this line, they meet at a particular point, right? The line intersects the parabola at the vertex. So if the vertex has an order pair x comma y, for example, then the axis of symmetry is going to be x equals whatever that value is, okay? So the formula for finding your axis of symmetry is x equals -b over 2a. And you can label your A, B, and C's based off your equation, right? Your function. What's the value of A? -1. Value of B? 8. Value of C? -18. Okay, so you plug things in. So negative B would have been -8, and then 2 times A would have been 2 times -1. So what's -8 over -2? 4. So x is equal to 4. So there's an axis of symmetry at 4. Basically, there's this vertical line that can cut that graph into 2 equal halves, right? It's like if I fold this blue booklet in that line, you can see that the 2 flaps, they meet, right? It's symmetric. Okay, so you have part A done. Part B, when you're finding the vertex, after you get x equals 4, after you solve x equals -b over 2a, you take that value and you plug it in to your function to get the y value, right? So when x is equal to 4, solve for y. That's what basically completes the vertex. So we're plugging 4 into our function, f of 4. So that's negative of 4 squared plus 8 times 4 minus 18. Okay, what's 4 squared? 16. 8 times 4? 32. So we get -16 plus 32 minus 18. So just be careful there. The 4 has to be squared, then multiplied by negative. So -16 plus 32 minus 18. What do you think that would be? Take -16 plus 32 first. That's going to be negative. No, that's going to be positive 16. So you have 16 minus 18, which is -2. So your vertex as an ordered pair is the following. Your vertex, you can say, is 4, -2. Okay, so we did part A, we did part B. Let's do part C and then we'll do the graph. So part C, I'm just going to read it back out. It says determine whether there's a maximum or minimum. So I'll give you a hint. The vertex, depending on your parabola, will either be the maximum or minimum. So what do you think? Is this vertex going to be a max or min? It's a max. Why? How do I know it's opening upside down or downward? Say again? Not the x. The value of a. That's right. I got you. Don't worry. I was trying to elaborate that out of you. So let's write that in words. So since a equals -1 is less than 0, then the parabola opens downward. Okay, so we have something that like this is going on. It's a parabola, like a sad face that opens down. So that vertex now, if that's your vertex, that's your maximum. So 4, -2 is the location of the max. Right? The value of A tells you whether it opens up or down. So if A was positive, then it opens upward. Okay, so we draw our parabola. And good things actually happen with this parabola. So the vertex was 4, -2. 1, 2, 3, 4. 1, 2. So I'm going 4 units to the right, 2 units down. So I'm somewhere down here. Now, because the parabola, I plotted its vertex here. Because the parabola is opening downward, right? Opening downward, will it ever touch or intersect with the x-axis? No. If it doesn't touch or intersect with the x-axis, then there's no real zeros. So one of the things about graphing your quadratic function is that sometimes you can find its zeros, but in this case, you cannot. Factoring wouldn't help you. The quadratic formula wouldn't help you. Why? Because the zeros are not real. This graph, this parabola, is never going to touch or intersect with the x-axis. So you could have used, for a more accurate graph, you could use the axis of symmetry, right? Just drawing that dotted line. Right, the dotted line x equals 4 was our axis of symmetry. It tells me that if I choose a value 1 unit to the left or 1 unit to the right, like 3 or 5, plug it into the function, I can get an output value that they both share, right? So for example, if I computed f of 3, right, just plugging in 3 into our function, plus 8 times 3 minus 18. If I actually compute this, I can get a y value that works for both 3 and 5. Because if you're 1 unit to the left or 1 unit to the right of your vertex, then they both share the same y value. So let's work out this arithmetic. What's 3 squared? 9, so that becomes -9, plus 8 times 3, which is 24, minus 18. So what's -9 plus 24? Careful, -9 plus 24. 15. Yes, 15, and 15 minus 18? -3. So this is equal to -3. So if I went 1 unit down on that y-axis, I got 3, -3. You can also get 5, -3 for free because of the axis of symmetry. And you draw your parabola. That's right. I mean, mine doesn't come out nice. And I'm using technology, but that's your parabola nonetheless. So this was part D. Any questions? Now, if it did cross or touch the x-axis, then yeah, I could have find the zeros, the x-intercepts, plot those, and the story when I connect the parabola, connect the 3 points. But this was just an alternative. Questions? Yeah? Sure, go ahead.
Yeah, we're recording this. It's gonna go live tomorrow on YouTube, so I'll send you guys all a link.
Mm-hmm. That's right. Any other questions? Yeah? Oh, this particular 3? This one here? Oh no, I just went 1 unit to the left of our vertex. So if I went 1 unit to the left or 1 unit to the right, then they both share the same y value. So I didn't have to do f of 5 because I know that f of whatever I get for f of 3 is the same thing as I'll get for f of 5. Okay. All good? Knowing Raphael, he'll probably put the one where you got to find the zeros.
Yes. It's a huge hit. That's which one is that one?
Graphing the quadratic.
Yeah, it's on a.
Yeah. Huh?
You see how here?
Oh,
You're below.
you're gonna have a graph that is gonna touch or intersect with that x-axis. That's right. Mm-hmm. Find the zeros. Yeah, you can find it. You can find it. Huh? It depends on if he axes it. If he says find the y-intercept, find the y-intercept. I got find the y-intercept for something else, something much better. Huh?
Chris, I'll tell you this, I will not ask it. But if you know how to find it, it makes your life much easier when you try to plot.
Mm-hmm.
Because find the y-intercept, vertex of the zero, that's all.
Mm-hmm. Yep, that's right. All right, let's continue. So problem number 9. Now we're going backwards. You see, problem 8, you got to graph a parabola. Number 9, you're given a parabola and you got to write this equation. When you write the equation of a parabola, you can use the alternate form, right? So problem 8, it was in the form of ax squared plus bx plus c. For number 9, you can use the alternate form of a parabola or the alternate form for a quadratic. Do anybody know that formula? The alternate form for their quadratic? I'll start it off. I'll say y equals, but then can somebody help me finish the rest? No? No? Go for it. A. That's right. Plus k. There you go. So A still tells you, by the way, the direction if the parabola opens up or down, right? HK, what do you think the HK stands for? HK has to be the vertex, damn right. And A, of course, tells you if the parabola opens up or down. So just looking at this parabola, is A going to be a positive number or a negative number? Positive. We definitely know, just a side note here, A is positive. Okay, so what is my vertex? -2, comma, -1. So that's my vertex, bang, right there. -2, -1. So I can plug it into my alternate form right away, right? We're going to get y equals a times x minus -2 squared minus 1. Now, if you look at it inside the parentheses, x minus -2, you can convert that to, or change that to x plus 2. So this becomes y equals a times x plus 2 squared minus 1. Now, I would say we would have been done, but no, unfortunately, no. When you write the equation of the parabola, the only 2 variables that should be remaining there is x and y. But what other variable is there? A. So you got to find A. The way that you find A now is simply choose another point that's on this graph, plug it in for x and y, solve for A, and then you just rewrite the whole damn thing all over again. With this time with your vertex and A. So what's an easy point I can identify here? 3. What does that 3 represent? That's the y-intercept. So as an ordered pair, it's 0, 3. Yep. So here you have 0, 3. We're going to choose that point. So I'm going to say chose 0, 3 to find value of A. Okay. So remember, 0, 3 means that the y value is 3, x is 0. So this is 3 equals A times 0 plus 2 squared minus 1. All right, let's work it with inside the parentheses. What's 0 plus 2? 2. 0 plus 2, my bad. No, how you said 0? No, 0 plus 2 is 2. 0 plus 2 is 2. So 2 squared is 4. So you get 3 equals, instead of saying A times 4, you write it the other way around. You say 4A. So you get 4A minus 1. Okay. Now you add 1 to both sides of your equation because the whole point of this was to solve for A. So you get 4 equals 4A. So if 4 is equal to 4A, what does that tell me about the value of A? A has to be 1, right? You divide 4 on both sides. So you put all this information together, right? If you put all this information together, right? I'll do it inside the parabola. Since the vertex is -2, -1, and A is equal to 1, you have that this parabola and its alternate form should be y equals 1 times x plus 2 squared minus 1. Right? Originally, we said y equals a times x plus 2 squared minus 1. I replaced the a with 1. And you can just simplify this a little further. Anytime you take 1 times any number, it's just what? What's 1 times any number? Yeah, any number that was multiplied by 1. So you can say that this is just y equals x plus 2 squared minus 1. Raphael, any curveballs they should know about?
This one?
Yeah.
Nah, not for this one. Actually, related to this, I may ask you to complete the square. It's not. Typically, when you complete the square, you have a quadratic that you cannot factor using our conventional. What you do is you add the term b over 2a square on the equation. So you add it and subtract it, and then you factor by doing that.
Mm-hmm.
So I may ask, tomorrow I'm going to send you all a list of problems with extra problems for you guys to do. And you mimic exactly the exam on Monday.
Oh, your exam's on Monday?
Yeah.
Ooh,
So
what a good
question
Thanksgiving
one,
gift.
it's gonna be very similar, just different numbers. It's gonna be exam. So
Wow, right before Thanksgiving, you guys get an exam, and then right before Christmas, you got a final exam.
yeah, the finals on 21st.
I know.
Crazy.
First time in like years, it's in the 20s.
No, I always get it in the 20s.
No, I mean, it's like in person though.
Oh yeah.
It usually always be like, for me, I always got it
class,
that week.
My class knows that I upload grades when on Christmas Day.
That's right. I said the same thing to my students too. Do it in the morning, get it.
That's right. 7 a.m. I wake up very happy to grades. I don't get gifts anymore, so you know. I have no Christmas tree to go to. So I go to my laptop and put in the grades. I was like, oh.
Then you send a happy holidays message. The grades are in. Happy holidays.
I actually don't do that though. I don't want you guys to bother me on Christmas.
All right. Let's look at problem 10. All right. So we did the graphing a quadratic, writing the equation of a quadratic. Now you solve an application of a quadratic. So Raphael and I, we both do this slightly different, but we still get the same results. I use bigger numbers here, but I don't think that's going to be a problem. So the way that I want you to solve problem 10 is I need to think of 3 letters, P, Q, and R. It works. Why does it work? Because if you know your alphabet, you know that P, Q, and R, they all come like consecutively. Right? If you sing your alphabet, it comes consecutively. But more importantly, it stands for 3 important things. What does the R stand for in this problem? Without me even reading it, what do you think the R stands for? A revenue, right? So I know that the R, I'll put that over here, stands for revenue. What does the P stand for? A price, and Q? Quantity. So if you put this together mathematically, we say price times quantity is equal to the revenue. So when you're going to read this problem, 2 things that you have to obtain. From reading it, you got to develop or construct the price function, P of X, and then you have to construct a quantity function, Q of X. When you multiply those 2 functions together, that's what gives you R of X, your revenue, okay? PQR. So what I do is the following. I figure out what the P and Q are, what the functions P and Q represent. So I write it out. So this is where I go and I read the problem and I start putting things in. So a publishing company charges $60 for a pre-calculus textbook. That's our first sentence. So that $60, that value there, where do you think that will go? Into the price or the quantity? Price. So I know that for P of X, it's going to begin with the number 60. At this price, the company sells how many textbooks? 8,000. So where would the 8,000 go? Yeah, it goes for the quantity. All right, so we have the 60 so far, and we have the 80 for the quantity. I have to develop now the function. So I need x, right? If you notice, I defined it as p of x, q of x. I only got the numbers so far, but now I got to figure out what will be my x's. All right, so when the company raises the price by $2, they sell 100 fewer books. So let's begin with this raises the price by $2. Are they only going to raise this price by $2? No, but it says for every $2. So let's think about the multiples of $2. That's going to be what? 2. What comes after 2? 4, 8, and so forth, right? So we don't know how many times he's going to raise this price, but we can write out an expression to represent it. What would that expression be? 2 what? No, just 2x, right? It says when the company raises the price by $2, they sell 100 fewer books. So every time that they increase the price by $2, 100 fewer books are going to be being sold. But more importantly, it completes, oh my bad, it completes my price function. It's 60 plus 2x, where again, x, bless you, x is the number of times the company raises the price. So if they raise it 5 times, right? If they raise, if x is 5, meaning they raise it the price by 5 times, then how much did they raise it up by? By $10. Okay. Now, let's take care of the fewer than 100 fewer books. How can I write that out mathematically now? Minus 100, but I need a variable. So it's a minus 100 what?
X.
Minus 100x. Right. So if they raise the price by just one time, then they're selling 100 less books. But if they raise the price 5 times, then the price function goes up by $10, but the quantity goes down by how much? 500, because 100 times 5 is 500. Okay, so that's how I set up this problem. I know it's PQR. When I read this problem, I should distinguish what's P and Q. What's my original price? What's my original quantity? Then from the rest of the problem, I should distinguish now, how can I translate that into an algebraic expression that involves my variable, namely my variable being x, okay? So we have our 2 functions. Price is going to be 60 plus 2x. Quantity is 8,000 minus 100x. All you got to do is multiply these 2 together to get your revenue, okay? So revenue function, R of x, again, equals P of x times Q of x, is going to be equal to 60 plus 2x times 8,000 minus 100x. All right, so we got to work this out. I have to multiply it. I have to form that revenue function. Okay, so I'll show you how this is done. Look at 60 and the 8,000. How many zeros are there between those 2 numbers? If I want to multiply, let's say 60 by 8,000, how many zeros are present? 4. So I know that when I multiply 60 times 60 times 8,000, it should end with that 4 zeros. Now, what's 6 times 8? So you put it together. The 48 goes in front. So it's going to be 480,000. All right. What's 60 times negative 100x? Negative, say it again. Negative 6,000x. Right? Because how many zeros are there between 60 and 100? There's 3 of them. And you just multiply the 6 by 1. You get negative 600. Oh, 6,000. Okay. Now you take 2x times 8,000. So what's 2 times 8? 16. How many zeros are there? 3. So you put it together, it's 16,000. So it's 16,000x. Okay, now you take 2x and you multiply it by negative 100x. So what's 2 times negative 1? Say it again. Negative 2. How many zeros? 2. So it's negative 200 x squared. Very good. Can I combine like terms? Yeah, what terms can we combine? Yeah, negative 6,000x plus 16,000x. If you combine this, is how many x's? 10,000. Positive or negative? Positive, that's right. So you get 480,000 plus 10x, 10,000x minus 200x squared. Now, technically speaking, this is good answer for your revenue function, but you can rewrite it where it's descending order for your powers. So your revenue function in descending order should be negative 200x squared plus 10,000x plus 480,000. 480,000. That's our revenue function. But we're not done yet. There's more. But wait, there's more. That's right. What was this problem asking us to do? It says, yeah, well, careful. It says use an equation to determine what price should be charged for this textbook in order for the company to maximize their revenue. Well, look at your function again. Well, we're dealing with a quadratic function. So where would the maximum be located at? At the top. More importantly, what do you call that top point of the vertex? Okay. So how would you find the vertex if you wanted to find it? Negative 2b over 2a. So from this revenue function, you set x equals to negative b over 2a. After you find, you figure out what's the values of b and a. What's b in this problem? And a? Negative 200. So you get 10,000 divided by 2 times negative 200. Say again? Oh, you're right. You're right. Thank you. Negative 10,000 divided by 2 times negative 200. So what's 2 times negative 200? That's negative 400. So negative over negative is positive. So I know that those two negatives are going to go away. Now, here's another way of simplifying this. How many zeros are in the bottom? 2. How many zeros are on that top? Careful. How many zeros do you see in 10,000? 4. So you could cancel out those zeros. What you're left with is 100 over 4. And you can reduce that even further. What's 100 over 4? 25. So what does this 25 interpret as? That means, if you look back, in this problem, I said that X is the number of times the company raises the price. So if this company wants to make a maximum revenue, they have to raise this price 25 times, okay? But we're not done yet. There's even more work to do, okay? So once you solve for X, you now answer the question at hand. Look back at the way the question 10 is worded. It says, use an equation to determine what price should be charged for this textbook in order for the company to maximize their revenue. So what variable am I solving for? Am I solving for P, Q, or R? If you say R, you're wrong. You're solving for P. This problem is asking us to find this value, the price. Do I have a price function? Yes. The price function was 60 plus 2x. So in that equation, I plug in the value of x that I found, which was 25, and I get my final answer, right? So lastly, the price needed to maximize revenue is the following. So using this notation, function notation, you got to compute P of 25, right? You plug 25 into the price function. So the price function was 60 plus 2x, and x is 25, then you got to compute 60 plus 2 times 25. So what's 2 times 25? 50. 60 plus 50? 110. So you get $110. That's the price. So any questions? Pretty good problem. I'm just gonna slide it back up. That's where it technically started from. Just remember the three letters, P, Q, R. Alrighty, let's I'm just gonna look at the time real quick. I know it's 7:47. Your class usually ends at 7:40, right? I know it's late. I know you got your family to go to. I'm gonna still do this review. I'm still gonna finish it, so that way you guys can have the recording. But if you have to go, feel free to do so. I won't hold that against you. Only Raphael will, because you have your midterm Monday, or your second exam.
How many more questions?
Yeah, how many more?
I have 5 more. I got 5 more.
It's gonna be on YouTube.
It's gonna be on
Yeah.
YouTube.
So, we'll keep going for the space.
Uh-huh.
What are the other 5 questions on?
I got leading coefficient tests,
We need that.
finding the multiplicity of the zeros,
That's okay. They don't need that one.
simplifying polynomial by long division.
That one.
14 is complex rational expression,
We'll do that again.
and
I would suggest you guys stay for the next question. And then you need to go for the last 4. That's what I'm going to do. This exam is going to be the final. I'm going to cover that again. Everybody else is online or in Tanya's class, you need to stay because that's covering your exam beginning on Monday.
that's right. We have a couple of people in there. Alrighty, so I just showed question 11, so that way those that are in attendance, you could feel free to go, especially if you're in Raphael's class. But I think if you're in Tanya's class or the other pre-calc section, you should stick around. Okay, so problem 11, using the leading coefficient test to determine the end behavior of these functions. So if you look at f of x, it's negative x to the 4th minus x cubed plus 20x squared. I'm not going to write out all the rules, but you guys will answer these questions as I'm showing it. What is the degree of your function? That's right. What is the degree of your of your function f of x equals negative x to the 4th minus x cubed plus 20x squared? Say again? 4. It's always the highest power. Of a polynomial, the degree is always the highest power. Okay, so what is its leading coefficient this time? Leading coefficient is not x. It has to be a number. It's not 1. Not 1,000. Negative 1. Can't be 1,000. Look what 1,000. Well, 1,000 wasn't even in this problem. Leading coefficient was negative 1. Okay, so let's talk back about our degree again. Degree of our function f of x was 4. What type of number is 4? Even or odd? Even. Okay, so now you could apply your leading coefficient test. If the degree of the polynomial is even, but its leading coefficient is negative, what do I know about the very end behaviors? Is it going to be opening up or down? Is it, you can do it with your hand if you like, your arm. It's not going to be up, it's going to be down. It's going to be like how LeBron James, when he does a slam dunk, he taps the shoulder like, and goes down. So it's like that. So how do I write this? I would just show you the calculus way of writing it, but I'll say this. I'm going to abbreviate this. I'll call this LCT real quickly. By LCT, by the leading coefficient test, you can say that f will open downward from both directions. Huh? What does the what? Oh, no, that means it goes in one goes opposite directions. So like, I won't know what's going on with this function. Like I have no idea what's going on in that center there. But what I know is that from the very end, the boat goes down. That's LeBron when he's on his on the DL list. Yep, there he is. All right. So there we go. That's the first one. Let's look at the second one. What is the degree of your polynomial? The degree of your of G is going to be 5. Okay. So we know that 5 is an odd number. What is your leading coefficient? Leading coefficient here is going to be 8. Okay, so what can we say by the leading what can I say now by the leading coefficient test? You gotta be careful now. With the degree being odd, that the two ends go in opposite direction. So if the leading coefficient is positive from the left, will it go down or up from the left? Think about your graph. I don't care about the middle piece. I care about the very ends. If I have an odd degree polynomial, it goes down. And from the far right, it goes up. There you go. That's your leading coefficient test right there in that picture. By leading coefficient test, our function, which I call G, by the way, will, we could say fall to the right, to the left, sorry. Fall to the left and rises to the right. And that's it. If the leading coefficient test here was, if the leading coefficient was -8, then it would have been opposite directions. It would have went negative to the right, fallen to the right, whereas it rises left. Okay. What? Yeah, I know, but this is better to use. This, I can't even find the point. Oh, now I found it. The last time I missed, I was like, where was the pointer? Couldn't find it the last time. All right. So again, if you're in Raphael's class and you got to go, then enjoy your night. Look out for his email. You're in time this class? What's up, man? Good work. Let me just pause this real quick.
There were
5. We only need 4 problems to go. Well, 6. We got to include the one more that's in the meeting. All right. So let's keep going. Problem 12. Find the zeros for the polynomial function and give the multiplicity for each zero. State whether the graph crosses or touches the x-axis and turns around at each zero. So for this particular problem, all you got to do is just doing this the fair way. But all you got to do is just take the x - 3, x + 4, the binomials, set them individually equal to 0, and solve for x to get yours, to essentially get the zeros. So if you do x - 3 = 0, x is equal to what value? 3. On the other hand, if you have x + 4 is equal to 0, then x must be -4. So we got to give the multiplicity now of each of these zeros, right? We got our zeros. Now we give the multiplicity. So how many times do you think the graph will have a zero of x = 3? Yeah? Say again? Oh, if you have x + 4 = 0, then you subtract 4 on both sides. You got to solve for x. So here it cancels. Okay. On the other hand, you had to add 3 here. That's why. Okay, so look at x equals 3. What do you think its multiplicity is going to be? I give you a hint. Look at the binomial, x minus 3. Technically speaking, what power is it raised to? What number was that? 1 is the number 1, right? So you have the multiplicity of 1. Whereas if you look at x equals -4, look back at the original binomial, x plus 4. It was raised to what power? It's a multiplicity of 2. Now let's compare these numbers. If you have a multiplicity of 1, or just the number 1, is that an odd or an even? No, the number 1, is it odd or even? Odd. And if you have multiplicity of 2, is that odd or even? Even. Okay, so the last part of this question was just simply state whether the graph crosses or touches the x-axis and turns around. If the multiplicity is odd, it crosses. Okay, so if you have multiplicity 1, 3, 5, 7, any odd number crosses. But if it's an even, it will just touch and then turn. So here it touches the x-axis and turns around. To give you a sense of what this graph looked like, look at your multiplicities. You had a multiplicity of 1, multiplicity of 2, right? If you add that up, how many multiplicities do you have? What's 1 plus 2? 3. So technically speaking, I'm dealing with like a polynomial of degree 3. So if I deal with a polynomial of degree 3, and I know that because there's this 5 on the outside there, roughly speaking, it has the behavior of this graph, of what we saw in problem 11 of graph g of x. From the far left, it falls down. From the far right, it rises. Let me see if I had this correct. Yes, I do. So let's say now that at our zeros, let's say this was -4, and this was x equals 3. What I know is that at our 0 of -4, the graph is going to touch that x-axis at that point. It's going to turn around. I have no idea what the hell it's doing in the middle here, but I know that it's going to, as it gets closer and closer to x equals 3, it has to cross that x-axis eventually. Okay. So again, here, no idea what's going on. In fact, we will, if you take calculus 1, we get to fill in that middle piece. But we're just with pre-calc, you get the end behavior and you can get your zeros. Okay. Any questions? The answer is just what I wrote out. It's not part, the graph is not the answer, but I just want to show you what we did. Okay. All right, let's look at problem 13. Well, do you have any questions here? All good? So problem 13 states to simplify by using polynomial long division. If you want to use polynomial long division here, right, you have your divisor, your dividend. Good night. And you have your divisor. Good night. You got to be careful here. When you apply long division, make sure that the dividend is always written in descending order by 1, the powers. The powers are in descending order by 1. Technically speaking, what power is missing in my dividend? Not the cube. Well, think about it. Here's a cube, x cubed. Here's a x, so that x was raised to what power? 1, so what power is missing? Not 1. No. Again, this has an exponent of 3. Here you have an exponent of 1. So what's between 1 and 3? 2. You're missing the degree 2. So if you want to fill this in a little bit, you say that this is equal to x cubed plus 0x squared minus 10x plus 4 all divided by x plus 3. Okay, I just had to rewrite this where it's in descending order of the powers. Okay, so the x plus 3 would go outside of my division bar. And inside of it, I have x cubed plus 0x squared minus 10x plus 4. And now I could start solving this problem. So let me ask you this question, just aside here. How many times can x go into x cubed? In other words, if I had this expression, x cubed over x, what would this reduce to?
X squared.
This would reduce to x squared. You see, if I ask the question, how many times can x go into x cubed? It's equivalent to saying x cubed divided by x, which turns out to be this x squared, okay? So we write out the x squared, and now we're gonna multiply x squared by our divisor, x plus 3. So what is x squared times x? X cubed. What's x squared times 3? 3x squared. So you have x cubed plus 3x squared. You put that inside underneath the dividend, and you put a subtraction sign, right? So you said minus x cubed plus 3x squared. And I got to work out the arithmetic. So what's x cubed minus x cubed? Right? In other words, what's x to the third minus x to the third? 0. That's just going to go away. Now, if I have 0x squared minus 3x squared, that will be what? That would be negative 3x squared. So you can do the work on the side. The side work can help you out here. So you get negative 3x squared, and now you could bring down the negative 10x. So you repeat the process. You want to ask yourself now, again, how many times can x go into the negative 3x squared? So equivalently, negative 3x squared over x. What would that be? Positive or negative? Try again. Negative. It's a negative value. So now I have to take this negative 3x, multiply it by x plus 3. So what is negative x times x plus 3? Negative 3x squared. And then negative 3x times 3? Negative 9. So, or negative 9x, you're right. So we're going to take negative 3x squared minus 9x. We'll write it underneath here. And of course, we're going to do subtraction. All right, so I ran out of side work to do there on the aside. So we can do this. What's negative 3x squared minus negative 3x squared? That will cancel out, right? So these two will cancel each other out. Negative 10x minus 9x, positive or negative? That's gonna be a negative x, right? So if you work this out, negative 10x minus negative 9x, same thing as saying negative 10x plus 9x, which is negative x. Okay, you bring down your 4, and you continue this for one last time. How many times can x go into now negative x? Positive or negative? Try again. It's negative. All right, so this will give us negative x minus 3. So we know that the x's should cancel. What's 4 minus negative 3? Try again. 7, because negative of negative 3 is positive. So you get 7. All right, so here's your final solution. Your final solution will look like the following. You write out your quotient, which is the x squared minus 3x minus 1, plus the remainder over the divisor. So your remainder is 7, and you divide it by the divisor. I think if you work this problem out on my lab, on Pearson, you will see that the x plus 3, they'll leave that alone. They'll give you that part. Oh, shit, it's touchscreen, forgot. But the x squared minus 3x minus 1, that's your quotient. plus remainder over divisor. Questions? Move this back out of the way. All right, we got 2 more to do. Yeah, got a question?
Is x plus 3 just under 7 or also under the entire solution?
No, only under the 7. It's pretty much this format. Quotient plus remainder r, right? Remainder over divisor. Okay. But again, for those that are doing this on my lab, all you really need is quotient and remainder. The divisor part is fixed. It's fixed. I'll give you that much. Any questions? Okay. Move on to problem 14. Okay, number 14, we want to simplify complex rational expressions. So like I said, anytime I see a rational expression, I try writing it out in its factor form right away. Looking at this, I can't really factor anything between the 3x minus 10. I can't factor anything from 3 and over the x plus 10. However, if you look at your denominator, 6 over x squared minus 100, you could break that down. You can factor that completely, right? The x squared minus 100 piece, you can, right? That's just a difference of 2 squares, which is what? Yep. So this will give us 3 times x minus 10 minus 3 over x plus 10, all divided by 6 over x plus 10 times x minus 10. Okay, so here's why I write this out. In fact, when I factor it completely, I look for my LCD, my least common denominator. Once I have my least common denominator, I multiply everything by it. Meaning, once I find the LCD, I'm going to multiply by 3 over x minus 10. I'm going to multiply it by 3 over x plus 10. I'll multiply it by that entire denominator, 6 over x plus 10 times x minus 10. So here's how this works. Look at your numerator. Your numerator contains the binomials x minus 10 and x plus 10 in the denominator, okay? What do you think will be the LCD of your denominator? For example, if I have the numbers like 1/2 plus 1 over 5, what do you think my LCD will be between 2 and 5? What's the least common multiple that they have in common? For example, the 2 and the 5. Yeah, and you could do the same thing with 2, multiply it by 5, you get 10, right? So the idea here is that, okay, if this LCD is 10, because 2 times 5 gives you 10, then you could do the same thing with the binomials. Okay, because essentially we say that the binomials are prime of each other. So I'm just going to erase that parentheses here. Oh, my bad. So our LCD of the numerator is x minus 10 and x plus 10, the product of them. Now, if you notice closely, is that in the denominator of the fraction that's in the bigger denominator? Yes, it is. It's there. So I can multiply everything by this LCD and simplify. All right. So in the numerator, I have the 3 times x minus 10, but again, I got to multiply that by x minus 10 times x plus 10. The 3 over x plus 10, I multiply that by x minus 10 times x plus 10. And again, I do this in the denominator. Whatever it is you see in common, get rid of it. For example, from that LCD, when you compare that to 3 over x minus 10, what do they have in common? X minus 10. So you can get rid of it. If you do, you're clearing your fractions, clearing your denominators. So you're getting 3 times x plus 10. No denominators anymore. The denominator is technically 1. All right, let's look at the next one. X minus 10 times x plus 10. That's your LCD multiplied by the 3 over x plus 10. What can I cancel? You can cancel out the x plus 10. If I cancel out the x plus 10, look what's remaining. There's a negative sign in front of that 3. So I'll say minus 3 times x minus 10. And now lastly, in the denominator, 6 over x plus 10 times x minus 10. All of that getting multiplied by x minus 10 times x plus 10. What can I cancel? Say again? Yeah, you could cancel out the LCD with your denominator, right? X plus 10s are gone, x minus 10s are gone. What's remaining? 6. All right, so now we've got to simplify that numerator. So we can distribute the 3 and negative 3. That gives you 3x plus 30. Negative 3 times x is negative 3x. Negative 3 times negative 10 is positive 30. And you divide that by 6. And you simplify this. What's 3x minus 3x? 0, so that's gone. 30 plus 30, 60 over 6. And you reduce this. What's 60 over 6? 10. So if you notice, this whole thing turned out to be just a number. It's the number 10. That's not always the case. Sometimes you get like something algebraic. But this is just one example of simplifying complex rational functions. What you should do is practice that one lesson. I don't know the number on my lab. If you're in Tanya's class, I forgot the lesson. The complex rational expressions. I forgot the lesson number, like the MyLab 14. I forgot the MyLab numbers, but you can definitely practice this. There's more examples. There's like different variants to it. All right, any questions? Okay, let's do the last one. There's no more people in the Zoom meeting. We'll do the last one and that's it. Yeah. I know. Okay, so number 15 states to sketch this graph, your graph must include the following: x-intercept, y-intercept, vertical and horizontal asymptote, and any additional points. All right, it's not that bad. We did like 2 hours and 15, so 2 hours, 30 minutes. Not bad. Oh, it was lesson 13? Lesson 13, Tanya's class, the complex rational expressions. For everybody? No, I changed things around. I know. Oh, nobody's changing this now. That's right. Okay. So f of x is equal to x squared minus 5x plus 4 over x squared minus 4. So first things first, I take my function and I write it in its factor form, just to see if things cancel out. If things cancel out, it makes my life a little bit easier. So x squared minus 5x plus 4. Can I factor that? Can I write it in factor form?
X minus 1, X minus 4.
That's right. It's x minus 1, x minus 4. What about the denominator, x squared minus 4?
X plus 1, X minus 1.
No, unfortunately, no. It's x squared minus 4. These ones are tripping you up today. What was the thing that Hanges used to say? It's either 0, 1, or e.
X
So,
minus 1, X plus 1.
huh?
X minus 1, X plus 1.
No. Look at the number that comes after the minus. It's x squared minus 4. So 1 times 1 doesn't give you 4, but what number does? 2. So it's x minus 2, x plus 2. So unfortunately, in this function, can anything be canceled?
No.
No. Unfortunately, no. Too bad. But I do know that I have problematic inputs, right? I know that in my domain, x will never be equal to what 2 numbers?
Positive and negative.
That's right. So because I didn't cancel out the x minus 2s and the x or the x plus 2, they couldn't be canceled. Then when I said x cannot be equal to plus or minus 2, they're going to definitely be vertical asymptotes. Okay. If I were to cancel them, then one of them, then whatever's remaining, that would have been a vertical asymptote, whereas the other one would have been a open point, a hole in your graph. But again, that's just a quick heads up there. But if you want to now sketch this graph, you do it in this following order. It's like a 6-step thing. Step number 1 is that you find the y-intercept. Well, we saw that a little earlier, I think, right? If you want to find the y-intercept, you always let x equals 0, right? Let x equals to 0. So this will be f of 0 is simply 0 minus 1 times 0 minus 4 over 0 minus 2 times 0 plus 2. So if you work this out, 0 minus 1 is -1. 0 minus 4, -4. So -1, -4 is, no, you multiply it. No, +4. It's okay. It's been a long day. 0 minus 2 is -2, and 0 plus 2 is 2. So when you multiply that, -2 times 2 is -4. So -4 over -4 is what now, Ricardi? -1. There you go. You finally got it. There's the -1 coming into play. So we got f of 0 is -1. And this gives you your y-intercept, right? So our y-intercept here, as an order pair, I'll put it down here because I want to do the x-intercept next. The y-intercept as an order pair is 0, -1. So I'm going to put a star on it because we're going to graph it soon. Okay, now we go on to step 2. Step 1 was find the y-intercept. Step 2 is now to find the x-intercept. To find the x-intercept, it's a little bit different now. We're going to follow this pattern. Here, technically, you would have let y equals to 0 solve for x, right? The shortcut to this, because you have a rational function, is just setting the numerator equal to 0 and solve for x, right? So set the numerator equal to 0, solve for x. So your numerator, which was in factor form, x minus 1, x minus 4 equals to 0, then when you split this into 2 equations, you're going to get your zeros. So the first case, x minus 1 equals to 0, that tells me x is equal to what number? +1. And the other one is x is equal to +4. So as order pairs, this is 1, 0 and 4, 0. Right? I'm putting stars on them because I have to plot them a little later on one of the upcoming steps. So we got rid of the intercepts. Now you can get the asymptotes. So here's step 3. Step number 3 is finding the vertical asymptotes. So I already gave it away what the vertical asymptotes were. I told you that because x cannot be equal to 2 or -2, they're not part of our domain, and because nothing was factored out, then those are our vertical asymptotes. But if you want to show it algebraically, all you got to do is just take the denominator, set it equal to 0. Okay, so for the vertical asymptote, you set denominator equal to 0 and you solve for x. So you have x minus 2 times x plus 2 is equal to 0. You got x minus 2 is equal to 0 in one case. The other case, you got x plus 2 is equal to 0. X minus 2 equals 0 is x equals 2, obviously. X plus 2 equals 0 would have been x equals -2. So those are vertical asymptotes, abbreviated as VA. Oh shit, I'm running out of room. Okay, so now we'll do step 4. So here it is. Step 4 is the horizontal asymptote. When you do the horizontal asymptote, you compare the degrees of your numerator and your denominator. So let's look at the numerator and without the factor form. What is the degree of your numerator without the factor form? 2. What about the denominator? It's 2. So if you have 2's, degree of numerator is 2, degree of your denominator is 2. What can you say about your degrees? Are they the same, different, less than, greater than? They're the same. So if the degrees are the same, then for the horizontal asymptote, you just got to take the ratio of the leading coefficients. right? You just look at basically the values that are in front of the big powers, right? So you have HA is equal to Y. Your horizontal asymptote is Y equals X squared over X squared. But what is the leading coefficients of your X squares? 1, right? So that's just Y equals 1. All right, now we're ready to do steps 5 and 6. So sorry about this, it's a little bit sloppy. But steps 5 and 6 now is where you make your graph. So you plot your main features from steps 1 through 4. That's the first thing that you do. So we had a y-intercept of 0, -1. So I'm plotting that point. All right, that's 0, -1. We had an x-intercept, 2 of them, 1, 0. And the other one being 4, 0. So I'm plotting them. Right, so that's 1, 0. Here's 4, 0. Okay, now you also had the asymptotes. So the asymptotes is where the graph will never cross or touch these vertical lines. So they were x equals 2. So let's say that's here. Right, I'm using this dotted line. Don't worry about that. We have x equals, my class in the morning will. Without this, I won't be able to teach in the morning. X equals 2, and then you have x equals -2. Okay, so those are your 2 vertical asymptotes. I labeled them at the top there. So it's not the 6. I was basically saying steps 5 and 6 there. All right. And we have a horizontal asymptote of 1. Y equals 1. All right. So we have everything plotted. Now we go ahead and we find test values. So to complete this graph, you got to choose some test values. Okay. I have a couple of them already here, but I need some more. For example, look at x equals -2. I need a test value to its left. So what value can I choose? I could choose -3. So let's say I chose this value. To its right, I could chose -1. So in black, I'm writing out all the numbers I chose as test values. I chose -3, I chose -1, and I could have also chose +3. Now, if you were to do the math, if you computed, let's say f of -3, meaning if I were to plug this value into my function, you would have got +6. Okay, so if you think about it, the order pair -3, 6, is it going to be below or above the horizontal line? -3, 6. It's going to be above, right? So let's say that for loss of generality, let's say it's here. That's 3, -3, 6. Okay, so that was one test point. Let's say if I plugged in -1 now. If I plug -1, just looking back at my arithmetic, you won't get a very nice value for this one. You get an approximated value. So let's say that this is approximately -3. So if I plugged in, again, -1 into the function, the original function it was, one of the test points you get is -3. So -1, -3 would have been down here somewhere. Okay, so that would have been another value. That would have been, again, -1, -3. And now if I plugged in +3, I don't remember what I got, but we could double check that. Let's see, 3 squared, it's going back up here. 3 squared would have been 9, -15, and then 4. So 9 and -15 is -6. With that 4, it would be -2. with 3 squared is again 9. 9 minus 4 is 5. So you get negative 2/5. So that's gonna be a number that's like below, a little bit above the 0, -1. So it should be somewhere here. All right. So I plugged in all my test points. Let me just move that 3 out of the way. Okay, so when I plugged in 3, you would have got like 3 2/5, I think, or negative 2/5. Is it negative or positive? Yeah, negative. Okay, I have everything now to complete my graph. I know my graph came out a little sloppier than it intended, but we're all set. The thing about asymptotes is that, technically speaking, from the vertical standpoint of it, your graph never crosses it. Okay. The horizontal asymptote gives you the end behavior. It tells you basically what happens at the end. It doesn't tell you what happens in the middle, but we can figure out the pattern of what happens in the middle. If you start from the very bottom, right, look at your 3 points that are in the middle: -1, -3, 0, -1, and then 1, 0. Those points, is it increasing or decreasing? It's going to be increasing. So I should draw a curve that's technically increasing, but at the same time, is it ever going to touch the 2 vertical asymptotes? Will it touch? No. The only thing that it's going to be touching is the horizontal asymptote, which is okay. Horizontal asymptote is only end behavior, does not give you anything regarding the middle. So it's fair game to go something like this. You get really close. Basically, it's decreasing without bound as you get closer and closer to that -2. But then it has this increasing behavior as you get closer to x approaches 2. So it's not the most smoothest graph because the way that it dipped there towards the left of -1, -3, but that's okay. This is just a rough sketch. So there should have been more like that, really. I kind of botched it even more. That's okay. Couldn't be saved. So it's okay again that in the middle you're going through that horizontal asymptote. Fair game. The other points, such as -3, 6, that one, you don't have to worry about that much in terms of the curve. Think about being like a car in a parking lot where there's only 2 exits, right? If you have 1 exit up here, then it could only go up there. And if it had 1 exit going this way, then it would went down as well. That's what basically it does with the asymptotes. It's like a car parked in a parking lot, but there's 2 exits from like the garage of that lot, or exit in the parking lot from opposite ends. So in other words, from a graphical view, it gets really close to the horizontal asymptote. Shit. I would have had to extend this out even further. It would get really close to the horizontal asymptote as x is going to -infinity, but as x goes to +infinity, is getting closer and closer to x equals 2. Okay, it's trapped between the 2 asymptotes. Similarly, if you look at the right here, you have the 2 points that are trapped amongst 2 asymptotes, so they can't go nowhere. And that's it. It wasn't the best looking drawn graph, but that's your final solution. Do you guys have any questions? Nope. Alrighty.